Recording. There it
There we
is.
go.
Okay. So we are being recorded now. What I was starting to say is I would argue that if you started taking a course in Excel or trying to get a crash course in Excel and things like that, they'd start talking about, things that we really that you don't have to know, and you wouldn't necessarily get what you need to know. So I would suggest that you try to follow what we're doing. Come and ask Linda or me, or Tom Topol or someone in the math assistance area, or some of your friends. But it's not a full course in Excel that we're doing at all. It's a small number of functions, and in fact, I think we've talked about most of the computational things that we're using in Excel already. Okay, so I think either Linda or I can give you a better guidance on that than trying to find a crash course in Excel. I just fear that would be too inefficient. Okay, Kathy has a comment, I guess.
Um, well, Jim, could we have, is there any way for the quizzes when we have our grace notes that we could also have like a basic list of the math and Excel notes? Like for instance, when you're doing like Carrot Top 2 or times, but it's a star, asterisk, things like that
I
we struggle
let,
to
let me
do?
let me think about that, okay? And I'm not saying no, and I'm not saying yes. I'm just saying let me think about that.
Okay.
I really hope, though, Kathy, is that you and your classmates have done enough of these problems and things when we're, when we're to that point that some of this stuff is going to be second nature, okay? But let me take that under advisement, and we'll see, okay?
Okay. Okay.
All right, now, totally new topic now, everybody. But this is exactly what the LSA that I think it was Sierra, whoever was asking about that LSA, this is about that. So these are dealing with normal distributions. And please follow my, let's see, Linda, it looks like that pointer is you, isn't it?
Yep, that
And
is me.
that's okay. So just kind of follow along and point at things. Now, this is no brag, just fact. This is literally everything you need to know is on this slide about the normal distributions. But there's a lot of information here. So I'm going to talk about it. And the first thing that Linda started talking about last time was the table in your book. And so I'm calling that Z space. And those are the tables that are in your book, and Linda's kind of drawing circles around them or something. So those are the tables in your book, and we're going to do that. So that is Z space. Now there's much more involved than Z space, but we want to learn how to do the table in your book. And I'm telling you that the table in your book represents the normal distribution with mean of 0 and standard deviation of 1. And that's what I mean by normal 0, 1. Okay. Now there's also, and I don't want to talk about that yet, but there's also an X space over here. I guess I am pointing at it. There's also an X space that is the real world. And that is a normal distribution that is going to be mu and sigma. Now, the X space and the Z space are represented by that equation, and that's the Z-score equation, and that's Z equal x minus mu over sigma. So that means if Linda were pointing at the left hand part of the screen, that's X space. So that's where you get your X numbers, and you want to change them into Z if you're going the direction that arrow is. And so that is X minus mu over sigma. So that tells you what Z is over there. And you can solve that equation for X. And so if you go the other way, you get X is equal to mu plus sigma Z. And that gets you back to that other space. And these are area preserving mappings. Now, I'm going to say one other thing. Maybe it's two other things. There are two great problems. Given numbers, find the probability, and given probabilities, find the number. Now, Linda and I right now are going to focus on just the right-hand side of just doing things in Z space. We're going to focus on those problems. So Linda, advance the slide. Or wait, I can advance the slide, I guess. Or wait, maybe you should.
Nope, you can't.
Because you did something clever there, and someday you'll have to tell me what that was. But anyway, okay. Now, here is the table that Linda was teaching you from last time. And you do need this table, and I will give you a copy of this table in your grace notes. So you have to do that. Now, there's a bunch of things that Linda told you last time, but I'm repeating them here today. So first of all, looking at the table, the things inside the body of the table are, and just as I say there, those are and you might say, do I need to know this? Yes, you do. Okay, but those are probabilities. They're inside the body of the table. These are the areas indicated in the figure above. So you see those things in the body of the table are the area that's shown up there. So that's the area. And the area is the numbers in the body of the table, in the body of the table down there. Okay? Now, and I talked about given numbers, find the probabilities, and given probabilities, find the numbers. You might say, where are the numbers? Well, the number is the Z that you see up there in your little picture. In fact, go up to the picture there. Go up, yeah, there. That's the Z. So you see, that's a number. That's not an area. That's not a probability. That's a number. And so Z then, and going to where Linda was, Z is the number outside of the table. And so you see the Z's run down and across. Okay, and so that's where we get those, and those are Z-scores. Okay, now these have negative numbers on them, and the next one, Linda, the next slide. Thank you. The next slide, the table is set up the same way, except Linda will show you that the numbers here are positive numbers. So these are positive Z-scores, and you can see that, again, the areas are inside the body of the table, but Linda will show you the picture up there, and the picture is that area. Okay, so these are things that we're going to do. Now, the next set of problems, and I'm going to ask Linda to work through these with us. And so I'm going to ask her to work again, but we're just working in Z space now. So Linda, go ahead and advance the slide, please. Okay, now, Linda, pick one of those problems from number 6, okay? And I'm going to read it. It says,
I think we already did one of those last time.
which one did we do?
I want to say C.
Okay, all right, but we didn't do B?
I don't think so. We
All
did
right.
1 of 6 and 1 of 7.
Okay, I guess we should repeat it. So let's do, now, by the way, you can see that on B, it's got a Z there. That means it's in your book. It's the area under the standard normal table. So Linda, we're going to do number B, and that is minus 1.99. Now Linda, change this to, and I don't know if I was going to say change this to a. I'm going to do this one, Linda, and then I'll let you do another one. Okay, so
Okay.
Linda is going to change this to a whiteboard somehow.
Let's see. There we go.
Excellent, and I'm going to get my chalk. Now, my drawings are not going to be cool drawings, but you can figure it out. Now, remember, I had X space and Z space. I have no X space in this. I only have Z. So I'm drawing my bell-shaped curve. And remember that the bell-shaped curve was a mean of 0. So I'm putting 0 there as the mean. And I said that Z was minus 1.99. So you see, this is a 0. Positive numbers will be this way. Negative numbers will be this way. So 1.99 is over here, and this is minus 1.99. And I think, Linda, it said to the left of minus 1.99.
Yes.
Okay, so you see, I'm trying to find this area right here. And since this,
That's just me talking to everyone.
no, that's fine. And Linda, in fact, you may want to open that up too, because I think I'm going to give that to you. But I want to pause just for a minute here. And you see, it's important that you draw these bell-shaped curves, because otherwise you will get really confused. So I drew the bell-shaped curve. I know it was a Z because it said it was a Z. And on this side, and I'm talking about the area that is less than minus 1.99. Now I want to pause here, and it's in the appendices in the book. I don't know what page it's on. Yes, Kathy.
Are we, Linda, do you mean while we're in Ultra Collaborate, we're able to open it as well? How are we able to view both?
So if you open a new tab and go to Blackboard again, then you can bring it up separately.
Okay. Does anyone have any questions about why I drew this picture? And by the way, I drew the picture because I told you should draw pictures. It's going to help you. Okay. But does everybody see that that's what this question is asking for, is that area? And that's the table in your book. So I'm pausing here for B if people want to ask questions. And if I don't hear any questions, that means we're in good shape. Yes, Paula.
I know you probably said it, but the area that you colored, that's the part that you colored, that's the area that we're finding, right?
Yes, exactly.
Thank
And
you.
there's somebody got their hand underneath you. I'll find out who that is. It's Kathy, I guess, and then someone's under you, Kathy, too. Kathy, you go ahead.
And when you said we're looking at the Z space, not the X space, what is the X space exactly? I didn't understand.
Haven't talked about it yet, but that problem said Z.
So X space is if we were like given a data set to analyze. Because we weren't given a data set and we're only talking about the Z-scores and their respective probabilities, then you don't need to worry about X space at all.
Yet.
Oh, okay. Okay.
Yet. And by the way, Kathy, what I'm trying to do is I'm trying to do this one step at a time. Okay? And so that's why I'm making sure that people understand the step I've done. And by the way, before this period is over, we will do a real problem that has X space in it. Okay? And then you'll know. And the problem I ask you to do has X space in it as well. Lori, you have a question too. Go ahead.
Yes, so I was trying to do this kind of thing for our the number 3-1, but the bell-shaped curve, how do you do that in Excel? That's where I got confused.
This is not happening in Excel. You're using the tables. This is not happening in Excel. We're using the tables right now. Now, I will tell you that there are things that you can do in Excel that will do this, but that's more of an Excel course than I'm going to teach you in this class. So the way I'm describing this is the best way to do it. And I have had some students who had boyfriends or girlfriends or something like that who explained to them doing something. But sometimes it gets explained in a thorough way, and other times it doesn't. So I'm going to encourage you to follow what we do and probably do the problems the way I'm suggesting. Yes, Kathy. So Lori, to finish up your question, there's no Excel yet in this problem. Kathy, go ahead.
So for the LSA3, we would be opening up the normal tables in this tonight's PowerPoint on the slides. We'd have to find that if we don't have the textbook, and then we would have to create a PDF, or how would we be submitting just
So the tables were also given last week in the PowerPoint, so you also have access to them there. But I mean, you're really just kind of showing what you did. So you could even do this in Excel, just showing like the basic calculations, or even just writing in a cell, the probability is blank.
Okay, and those tables never, that's one table is for every problem, that table?
That's the Z table. That's the table in your book. And there are two tables, one for negative and one for positive.
Okay.
All right, so we have this. Now, okay, so now what we have to do, and Linda showed you how to do this last time, and I'm going to ask everybody to look. But here's what you're doing then. You're going to be looking, and we want the area, so that is inside the table. So I'm drawing something that looks more or less like a table, and I go down to minus 1.9. And then go all the way over here to 0.9. And it's this row and this column, so there is some number that is there. And everybody, please try this. What is that number? Everybody come up with a number for this. And again, this isn't a test, but I want to make sure that you know how to do this. And then Linda, let's see. I'm trying to think of what. Linda, can you see these things and can you tell me what the number is?
Yeah.
Go ahead, please. And by the
All
way,
right.
I'm going to write
I'm
that
getting 0.0233.
point
0233.
0233. Okay, so that is what we got. And Paula got that number too, so good for you. And that's the answer to this question that Linda just did. Now, I want to tell you, and Kathy, I'll be with you in just a moment. Okay, so that's what we have for this. Now, I told you there were two great problems. And this was a problem where, given a number, you find the probability. This is an example of given the number, find the probability, and we were just in Z space. Kathy.
Yeah, I'm sorry, Linda and Jim, I know you probably explained it. I had tried to go back over and find the normal tables. What is, when you find tonight's PowerPoint, is that the raw notes or what is that exactly called in the syllabus? I couldn't access it.
So
Linda,
that's raw notes 2.9. It should be at the very bottom of the syllabus tab. And once you open it, then it's on slides 9 and 10. So the negative table that we're using right now is on slide 9.
Okay, thank you.
okay, good. Now, all right, so we've done a problem now, and I've asked about questions and people got this answer, so good for you. And I'm doing this one step at a time, okay? Now let's go back to the PowerPoint, please, Linda.
Okay.
And Linda, I have to ask you because you remember you were paying attention last time. I wasn't so much. I don't think we did. Well, okay, let's do another one. Now this time I'm going to do number 7. Did we do any of these?
I think we did C as well. I can't remember exactly, but I'm pretty sure that was it.
Okay, well, we did C last time then, so that's good. But you see what this says, determine the area under the standard, and by the way, that says standard normal curve. Standard normal is the one in your book that lies to the right. Now, by the way, that's different. That says it is right instead of left. And you see there's a Z here instead of that. Now, Linda said we did C last time, so you can look at that. But we're going to do B this time, okay? So let's go to B. And Linda, let's go back to the whiteboard. And
Okay.
I don't know if I have to erase this or not. I don't. Linda erased it for me. Good for you. Thank you. Okay.
It does it automatically. I hate it.
Okay. All right. Okay. Now, the reason I drew this on the right side of the paper was why, Linda?
Because we're in Z space.
We're in Z space. That's exactly right. And damn it, Linda, I forgot the number was
Negative 1.59, I believe.
Okay, so that, now zero's in the middle of this. That's the 0. Okay, that's 0. So the negative is going to be over here. And I think I'm going to try to write that with the, actually I can draw better than this here, but I'm not going to worry about that. So I think Linda said this was a minus, and the minus does matter. So this was minus, and then I think she said 1.59.
Yep.
But the question said to the right of this. So you see, I want the area that's to the right of this one, right of this one. This is the right I'm talking about. So that is the area I want. But that's not what my table gives me. My table gives me this business here that's in my table. And Linda is saying, oh, you want the red stuff, what she colored there. Okay, now, so that's what we want. Now, we know from our videos and other discussions that the area, maybe Linda's lecture last time, that the area under this whole thing is 1, because the area under a probability density function is always 1. So what I'm going to do is, you see our table is going to tell us what this area is, but this is going to be 1 minus that area. So everybody's going to look in your table, and you're trying to find out what is the number that's in your Z table that is minus 1.59. And Linda, I'm just going to ask you to tell me what it is, but everybody do this because you want to practice this. Go ahead, Linda, what do you get?
That is 0.0559.
0.0559. Now that area is this area right here because that's what your table tells you. But then we're going to subtract that from 1. And Kathy, I'll be with you in just a second. So Linda, what do you get when you subtract that from 1? Actually, I can do that in my head, but go ahead, Linda.
So 0.9441.
Okay, so the answer to this problem is 0.9441. Now, Kathy, you have a question. Go ahead, please.
I didn't know if you thought we were watching a cursor when you were saying over here, over there. I only see what you're drawing.
Okay.
So the stuff in the table, and I'm going to circle this so it's easier to see. The table gives you this section in blue, because the table is always going to tell you the area to the left of whatever number you give it. So because we want this area to the right, which I'm going to kind of underline in purple here, then since we know the orange area and the purple area add up to be 1, then we can do 1 minus that 0.0559 and end up with the area that's in that purple spot. Did that answer your question or no?
No, I understand that part. I just thought we were maybe supposed to be seeing a cursor move or something. I couldn't see what
Well,
was
ideally you would have been seeing a cursor move, and I think actually if I had my pencil, maybe you can see my pencil. I don't know if you can even see that or not.
You can't see the pencil unless it's actually been written, but you can use the pointer finger to point to
Pointy
things.
finger, okay. All right, now, so I'm just going to say more or less what I said before, but you see your table gives you, and I'm saying what Linda said, but your table gives you this stuff, but what the question was asking it was for this stuff, okay? And so that's why we had to subtract it from 1, and the answer to this problem is 0.99 or 0.9441. Okay, that's good. Linda, let's go back to the, to the PowerPoint thing, and that'll
Okay.
erase this, and that's good too. Paula, is your hand up or did we finish with you?
Yeah, I have a question. So the table will
Yep.
always give us what's on the left?
Yes. Yes, it will.
And the reason we know this is because of the little drawing on the top left corner. So it points to where the area is. So you always know what it's referring to.
Oh, gotcha. Thank you so much.
All right, this time we're doing something different. We're going to do C again, And so this is going to be minus 1.04. So we want to be between this. And again, this is Z. I'm staying with the Z, okay? And that's what I have. And then it's 2.76. Okay, so Linda, let's go back to the whiteboard again.
Okay.
Now, again, I'm going to draw it, and I'm drawing it over here because this is Z. And so one of the numbers was minus 1.04. So that's over here to the left of 0. Okay, and I'm going to do this. So this is minus 1.04. Okay, but then the other number was 2. What was that?
76.
Thank you. So 2.76 is over here. This is pathetic, but I'm really much better than this on a chalkboard. I can't wait to get back into a classroom. But anyway, here we are, and this is 2.76. Now, an astute student would say, yeah, but my table doesn't give me that. Well, no, it doesn't give you the area between, but this is the area that we're looking for, is this area right here in between that. And you might be thinking, well, how in the heck can I possibly get that? Well, here's what we'll do. We'll say that, well, my table will give me that number, and my table will also give me that number. So the area I'm seeking is the difference between the two. So, and Linda's drawing an X space over there, but that's okay.
So I'm just giving a slightly different visual for it.
Okay, that's all good. Why don't you talk about your visual?
So this is the z-score for negative 1.04, and then over here would be the 2.76. So sometimes it can be easier to think of you're starting with this bigger amount and then taking off the tail at the end. So it's the exact same thing that Bradley said, but just rearranged in a slightly different way.
Paula, what's your question?
So 0 is in the middle, right?
0
Yes.
is in the middle because it's normal 0, 1. Yes, and it's in your book. This is Z space.
Okay, and you knew it was 2.76 and on that side because it's positive.
Yep.
Yes.
Okay, thank you.
Okay, Paula, there's someone underneath you. It's Kathy again. Kathy, you're often underneath there. That's all good. And when I say underneath, that's the way it shows up here. Kathy, you have a comment, or do you?
Yeah, I have a question. So can you tell me if I'm understanding this correctly? The 2.76 means that Z line is 2.76 standard deviations away from the mean. Is that correct?
You got it.
To the
Okay.
right side, but yes, exactly. Okay, everybody tell us, and everybody look this up in your tables, see what 2.76 is. And by the way, you have to use the positive table for that. And then everybody find out what minus 1.04 is. And Linda will tell us those two numbers in a moment. I will write them down on this thing. And so Linda, tell me the 2.76. Go ahead whenever you're
So
ready.
that gives you 0.9971.
0.9971, good. And then it's going to be minus, and what is this 104 thing?
Let's see.
It's
That
minus
gives you 0.1492.
1492, and then Linda's taking the difference between those two, and we're going to have the final answer for this problem right here. Linda, go ahead and tell me what you get.
Okay. I'm getting 0.8479.
0.8479. Okay, so that is good. Okay, now I'm going to pause and see, do you guys have questions on this? Yes, Kathy.
So our answer, is that essentially saying that I'm not sure if it could be either or. Is it saying that that final answer is 0.8479 standard deviations away from mean, or that's
No,
84%?
that's 84%. That's a probability. You
Okay.
see, again, the only thing we've done so far is we've done given numbers, find probabilities.
If you're taking numbers from inside the table, you're using probabilities.
I don't get what you mean when you say that, if you're taking numbers from.
Linda, go back to the slide.
You got it.
And I'm not being mean with this. I think the slide, actually, I worked on that slide for a long time, and I think it's a good slide. Linda, not that one. Go back to the slide where I was doing there. Okay. Everything inside the body of the table are probabilities, and they're areas in the figure above. The numbers are around the outside. So the inside body of the table are probabilities. Go ahead.
When you're saying probabilities, do you mean percents? That would percent of the total?
Same thing, yes.
Okay.
Except these really are decimal numbers, so they're not percents. You have to move the decimal point a couple places.
Right.
That would be 84%.
Okay.
Okay. And
So what
again,
it's saying is 84% of it falls in between that, in that little area, between the negative 1.04 and the 2.76.
Exactly. Yes. Okay. All right. Now, everything we've done so far is has been given numbers, find probabilities. Now we're going to do something different. Okay. So Linda, let's go back to those problems again, please. And now we're going to go down here, and we're at 19 through 22. And wow, I don't know. Linda, we're going to do number 22. Okay.
Okay.
Now what this says is find Z of, and then that says that probably is alpha. Okay. So that's Z alpha. Now this means this is a percentage. And so this means we're saying the area is 15%. Find Z. So you see, this is an example of the other problem. Given the area, find Z. And it's 15%. So Linda, please go back to the whiteboard then.
Okay.
And pretty soon I'm going to let Linda do something besides switching back and forth between these. But anyway, now again, that was a Z. So I'm still over here in Z space. So I draw that, and that one was 15%. And so this whole area is 1 or 100%. So 15% is going to be, can I draw a straight line with this? Yes, I can. I can do this better than I was doing. Yeah, there. Okay, that means that this area here is 15%. Oops, that wasn't what I wanted here, this one. Okay, so I'm coloring that in. Now, everybody understand this is a different question because what I've said is this area here is 15%. That is 0.15. Okay, so that is the area. Kathy, I'll be with you in just a minute. But then the question is, what is Z? Now, what this means, Kathy and everybody else, this means I'm going to look for the closest number to 15% inside the body of the table because this is a probability. It is inside the body of the thing. That's an area. And I'm going to look for the number that's closest to 0.15. And then I'm going to work backwards and see what Z-score gave me that. So this is an example of giving a probability, finding the number. Kathy, Kathy, I wanted to finish what I was saying before I recognized you. I was hoping I might have answered your question, but maybe not.
No, I was wondering, is it always going, like you started from the left to get to your 15? Would that always be the case, or can it be anywhere? How do you know where they're putting that 15%?
Well, the area of the whole thing is 1. The area of half of it is 0.5. So where would 0.15 be? It would be over here.
I think what she's asking is why is it on the left end instead of taking a slice like right here where that would be 15%?
Right, because it's a positive 15%.
What this is saying is that the area to the left of some number is 15%. And you see that's not true over here because Linda drew in red, and Linda drew two numbers, and I only told you one number. And so it's the area to the left of this one number is 15%. You see the whole thing is 1. Half of it, I'm going to draw that. Well, I didn't have the right tool. Hold on. In fact, I'm going to try to do a better job of drawing. I can do a better job of drawing. Half of it would be 50% because that's half of it. So this would, and this is 0, so that would be half of it. But so this would be, the area from here on is 50%. So where is the area to the left being exactly 15%? Linda, if you want to weigh in some more, go ahead here.
So, Kathy, it may be easier to think of it like if you're on a coordinate plane, then this would be 0. Except we're not talking about z-scores, we're just talking about where this is centered, basically. Because you can't have a negative probability. So the negatives are only your z-scores. But since we're starting with a probability at 0, then we're just slowly making our way to the right until we get to that 15%.
Okay, thank you.
Now we're going to be doing this backwards from what we did before. Previously, we looked at the numbers on the outside and found the probabilities inside. Now what we're going to do is we're going to look inside the table, into the body of the table, because that's a probability, that's an area. And so we're looking inside the body of the table, and we're trying to figure out what is the number, what z-score is closest to 0.15. So everybody take your z-table. This is the one, and you're looking for the positive area. This is going to be the one that has negative z-scores, and try to find the number inside that is closest to 0.15. Now, it's not probably going to be exactly 0.15. It's going to be close to 0.15. And Linda is going to tell me what she finds as the number that's closest to that 0.15. Linda, I'm asking you for the area, and then we'll do the z-score. So what is the area in the body of the table, Linda, that's closest to 0.15?
So there are two that are close. There is 0.1515 and 0.1492. Now the 0.1515 is actually 0.0015 away, while the 0.1492 is only 0.0008 away. So I'm going to go with the 0.1492, and that gives a z-score of negative 1.04.
Okay, so I'll do some spaces, and I think she said minus, what did you say?
Negative 1.04.
Thank you.
Which is actually the same number that we used in the last problem.
Questions on what we did. Now, this is the first example that we did of given an area, find the number. I'm taking this as a good, well, okay, Paula, yes.
Can you say again why you picked 0.1492 instead of 0.1515?
Linda saw two numbers that was between, and that one was closest. What she did was she took 1.5 minus that, and she said which one was closer. So that one is closer.
Thank you.
And by the way, we're talking about absolute values here. So I know that bottom one was negative, but that doesn't matter. It's the absolute value of that. Okay. All right. So that's math's a bunch of details, isn't it, Linda? Okay.
It sure is.
Yeah. Okay. We're good with this? Kathy.
So when you find your final answer, which was, I don't remember what it was offhand, but how
Negative 1.04.
negative 1.04. What I don't understand is if that's saying it's negative 1.04 standard deviations away from the mean, wouldn't that always automatically be 34%? Because
No,
it's
that's a
30,
little more. That's a little more than 34%. Okay.
but
It's
I
a
don't
little.
understand, how does that go with the 15%?
The
No, that
34% that you're talking about is actually between like -1 and 0.
Linda,
Right.
go back to that slide with the empirical rule. Kathy, I think
Okay.
this will be a better answer. So Linda's going back to that slide. This problem's done. Okay, but let's go back. So Linda's going back to the slide, the empirical rule slide. Okay. Okay, now you see, so Kathy, what's happening here, and Linda said if I do the pointy thing, you can see my finger. Can you see my finger?
Yep.
Okay,
Yes,
good. Okay, so you see the 15% is somewhere over here, okay? And so it's a little bit, it's a little bit more than one standard deviation. And Kathy, you're asking very good questions. Everybody's asking good questions, but that minus sign means it's to the left of the mean. Okay, so we're over here. But you see, that's not the 34% because we were talking about the area over here. Okay. Not the 34%. Okay, so that's good. Okay, Linda, let's go back to the slides. Or no, no, the slides. Let's go. Let's just advance the slides for a while, please. Okay, now we've done both problems, so we've done things with the Z space. Now what we're going to do is we're going to do an X space problem. Linda, I'm advancing the slide. I think I can do that. I did. All right, so now we're going to do a problem, but I'm going to read this to you. And Linda, I'm going to let you do this one, okay? Not because I can't do it, but just I want Linda to be more involved in this. So I'm going to read it though. Now, for all of these problems here, Linda, what variable do you see?
I see X's.
All right, so this is an X space. So Linda's actually going to draw an X space. And Linda's also going to realize that the X space is not going to be normal 0, 1. It's going to be normal mu, the mean is 50, and the standard deviation is 7. But we will have to go to the Z space to answer this. So what this is saying is, assume that in X space, its mean is 50, sigma is 7, and we're going to have to compute these probabilities. So what Linda is going to do is she's going to pick one of these to do, and I'll let her pick which one she wants to do. But then what she's going to do is she'll have to change the X to a Z in order to find out what these probabilities are. So she's going to use that Z equal X minus mu over sigma. And in fact, Linda, go back to that slide just for a minute. We're going
Okay.
back to my Z space and all that.
Got it.
Excellent. Thank you, Linda. And yeah, this is fine. Okay, but we're over here. Okay, so Linda's drawn one over here because that's in X space, but she's going to use this Z transform to get to Z space, and then she's going to look up the answer in her tables, and that's the answer to this problem. Okay, so Linda, I'm turning it over to you. So pick out which one you want to do. Tell the students which one you're going to do first.
I think I'm going to start with 27.
Excellent.
So first I'm drawing my X space graph just to give me an idea of what I'm actually looking at. So since my mean is 50, then I know that my line in the middle here is 50. Now then I have 40 on one end and 65 on the other. So 40 is definitely less than 50. So I'm just going to put that here. And then the 65 would end up on the other side. So this is my graph in X space. And what I'm finding is the probability between those two. So this is going to be really similar to that one z-score problem that we just finished, where we subtracted the two answers that we got from the table. Any questions so far? Okay, so remember that z equals x minus mu over sigma. So for this, what I'm doing, so that is x minus the mean over the standard deviation. So for each x, then I'm going to subtract 50, which they told me was the mean, and I'm dividing that by the standard deviation, which they told me is 7. Kathy, what's up?
Could you slow down and repeat that? I'm very confused of when you, like when you put in the 40 and 65, are you telling us that those are is that what we're trying to find, or I'm just confused?
Linda?
Yeah, so
Linda?
I'm doing number 27.
Right.
So it's the probability that x is between 40 and 65.
Okay.
So that's why I drew this picture on the bottom left-hand side. Are you okay with that?
I just don't understand, what is it, like, why is it the way it's written, p parentheses 40 x 65, that's just the way they're telling you find out what's in between here?
Yeah, so the way that that is read is the probability that 40 is less than x is less than 65. So basically they're giving you the lower and the upper bound, 40 and 65, and they just want the probability that x falls between those two.
Okay.
So that's why my graph is set up like one of the other ones that we did, where we subtracted all this area and this area.
From one.
Well, from each other, right? Because this is like where I drew the two graphs. So we have the one, and we're going to subtract off the lower amount.
So you're trying to find out first the 65 amount, the percent that falls in there, and then you're going to subtract.
Exactly.
Okay.
But before I can get those percentages, I need the z-scores so I know where to look in my table.
So this is x, and Linda is changing it by this x minus 50 over 7. She's changing it to z space. Go ahead, Linda.
So if I want this to be a z, then I'm plugging in 65 for x. So all I'm doing is just 65 minus 50 over 7. And that's going to give me the z-score for that 65. So when I do that in my calculator, then I'm going to end up with about 15 divided by 7. So I'm going to call that 2.14. And that is my z-score for this first picture up here. Is that okay with everyone?
Can you just remind us, how did you know to do that formula, z equals x minus m over sigma?
So that was another thing on your grace notes. So let me
go back to the slide, though. Go back to the slide, and I keep going back to this because I don't think people. Go back to the slide. It is on your grace notes. I'm sorry, that erased it. Okay, we were in X space, so there it is. That's what you do. Now, this is going to be in your grace notes, as Linda said, but that's why you're doing it, because I told you that when you go from the X space to the Z space, this is the way the arrow is going, you use that. So you see, you know what X is, and then if you plug X into this formula, you know what Z is. That's what Linda just did.
Are we all okay with that equation now? I hope.
Yes.
Okay. Then I will continue with number 27. So we found the z-score for 65, and I'm just going to write that down here. So that is 2.14. Okay? Just so we have that from all the work that we completed before. So what that means is my first picture for z-space looks like this. And I'll find the area under that curve using the table in just a minute, but I want to figure out my other z-score first. So to do that, I'm using the same equation as before. So z still equals x minus the mean over the standard deviation. So same thing, I'm plugging in 40 for x, minus 50, which they told me is the mean, and I'm going to divide that by 7, which they told me was the standard deviation. So when I do that, then I get negative 10 divided by 7, and that is about negative 1.43. So that is my z-score corresponding to the x value that was 40. So now I want to subtract off the probabilities that I'm drawing here. And then this one would be less than the mean at negative 1.43. Now using my z-score table, since now I have my z-scores, then I'm looking for what the area is that corresponds to 2.14. So I'm going to need to look on my table with the positive z-score values and find what is inside the table when I use the number 2.14.
Everybody do that. Everybody do that. And this is, and I'm not testing you, you're testing yourself. Everybody do that. And everybody look at their Z table for minus 1.43. And then Linda's going to tell us what those answers are, but you've checked yourself to see if you know how to do that.
Okay, so I'm going to continue with this. So the area that I got for this red graph that I drew, then I'm getting an area of 0.9838, which makes sense because since we have that positive z-score, then we're going to get a value that's over 50%. Now, when I find the area of my negative z-score, then I'm getting 0.0764. Is everyone okay with those two values?
Yes.
Yes.
Okay, so now that I have both of those areas, since what I'm trying to find is actually the area between these, so something like that, then I'm subtracting these two, so 0.9838 minus 0.0764, and that's going to give me 0.9074.
And so that's our final answer, correct?
Yes. That is the entire problem.
Okay, now there's a lot of problems here that you can practice on. And by the way, one of the things is Linda and I do a few of these, but you can go and practice some more of these, and that's how you get good at this. That's how you remember keystrokes and things like that. Yes, Kathy.
So until, if I'm going to order the book, but until then, just practice these and then come to like a guided study group and have someone check the answer, because I feel like I can
Yeah.
barely follow along, but I wouldn't even know how to get to some of the formulas on my own. So then I
Well, but when you try, and you will try, I know you will. When you try, what will happen is that you'll know things that you know or don't know, and you can check these you can check these answers, and that gives you things to that actually gives you good questions to ask. You could say, hey, I got 45 for something, then we can see if that's a correct one or not. So yes, Kathy, that's right for now. Okay,
okay.
and Kathy, there's someone underneath you, so it's Carolina, it looks like. Is that how I say your name?
Carolina.
Carolina, I'm sorry. Okay, Carolina, and I may or may not remember that. You have a question, go ahead, please.
Yeah, so the result we got it from z-score numbers. Will we have to like turn it back to an x? You know, like do another formula to like turn it back, or just it's fine with the z-score?
This problem didn't ask you that, and you see this mapping is the areas are the same in the two, and all they asked for you here was the area, so we didn't have to turn it back. Now, sometimes you do have to turn something back, and I'm really debating whether to do this, but in this one you do have to turn it back because you see, and this is the different kind, and Carolina, Carolina, I'm answering your question right here. And I don't know, we're getting
So
a
this
lot of,
is the two great problems that Professor Bradley described earlier, where you either have the number and find the probability, which is what we just did, or you have the probability and you have to find the number. That would be what you're talking about, turning it back into X.
and that's what's happening. What Linda was talking about is what's happening on problems 33 through 36. So you see what I'm going to do this one is I'm going to find the 90th percentile. The probability is 90, and I'm going to go back. Now, what I'm going to suggest is that okay, so here you see what they want to do is you want to find the indicated percentile for X. So you work this problem in Z like we did, but then you go backwards to find the X, and it's a different equation. What we do is we say, oh, I know Z, I know mu, I know sigma, and you solve for X there, okay? And so I think Linda, and this, oh, Kathy has a question, and then okay, go ahead, Kathy.
I'm wondering how would 0.9074, how would that be one number if that's, isn't it essentially saying that whole area is 90% of the entire area? How would it be one number? How would you change that? What does that mean? How would you change it to a number?
That means that well, wait, that's not what the problem was. The problem said it gave me numbers. Oh, you were talking about here in this one?
No,
See
and
over here,
Carolina
the
asked
one we
how,
just did? Yeah,
I'm
go ahead.
I'm not sure. Carolina was saying, would we change that back to X? And what I was confused
No,
about,
no, because we found the area already.
okay.
We found the area already. We didn't have to change that back to X. This problem we have to change to X. So what I'm going to do is, and I was really debating what to do here, and I think, now Linda, I'm thinking about this. The normal problem is due when? I think that's due on the 12th.
I believe so. Then there's another one due on the 19th, I believe.
All right, here's what I'm going to do, just because we didn't get as far as I hoped to, and I always know what time it is. So Linda, and can you remind me to do this just so I don't forget? I'm going to go change the due date on the LSA that was due on 12. I'm going to make it due on the I'm going to make it due after we meet next time. Okay? So it's going to be due on the 16th. I'm going to make it due. Okay? So it's going to be due on the 16th, but that's after we meet again. Okay. So you have opportunities to do, or maybe I'll make it 17th. So I'll make it due after that. Now, so what we're going to do is we're going to do one of these problems. And Linda, the one I want to do is the number 35, which is the 81st percentile. Okay.
Okay.
All right.
So I'm going to erase all of this. That way we have some room to work.
Why don't you give us a whiteboard?
Okay.
All right. Now that problem asks us, and everybody think about reading the problem. It's very important. That problem asked us for an X answer, didn't it? So that is an X answer that I want to have at the end of the problem. But this is Z space over here. Now, so what it said was that was the 81st percentile. And so that means that the geometry is going to be here. And so I want to find the number that is this area here going this way. All of this area is close to 0.81. Now, this problem, as it said, I should have typed 81. Okay, that's what I want to do. Now, but I wanted to have the X, but the first thing I need to find is, and I'm going to just call this, I'm going to call it Z81 right now. Z, and it should say sub 81, but I'm not going to spend the time to formate that. Okay, now everybody look in the body of your table and find what probability in the body of your table is closest to 0.81. And Linda's going to report back and tell us what that is.
So I got 0.88.
Okay, now so she looked and she said, now 0.88, that's the Z-score, right?
Yes.
Okay, now so she found, what was the probability first, Linda? Kathy will be with you in just a minute. What was the probability that you found that was closest to 0.81?
Let's see. That is 0.8106.
All right, so she looked in the body of her table and she said, oh, that's the closest one. And then you see this is given the probability, find the number. And now I think she told me it was 8 point what?
So that
0.88.
was 0.88.
0.88, and I keep typing fives. That is 0.880 is the Z-score. So this is the Z value. So Z is this. And now we're going to use that equation again. Go ahead and talk, Linda. Go ahead.
So since Z equals 0.88, then I'm using kind of the complement of our equation that we started with for Z-scores, where it was X minus the mean over the standard deviation. Yes, Kathy?
Yeah, let's recognize her. Go ahead.
How did you get to Z equals 0.88? I found a different, when I look it up on the chart, I find 0.7910.
What are you looking at? 0.7910?
I'm looking at standard normal distribution Z line 0.8.
Yeah, but we're trying to get as close to 0.81 as possible.
Linda, I think it's useful if you could go to the table, and I know you.
I think
Yeah, I can do
Kathy
that.
is looking at the Z numbers. Kathy, I think you're looking at the outside, and Linda's looking at the numbers on the inside.
Yes. So on the
Oh.
inside of the table, you're looking for 0.81 as close as you can get. And then once you find it, then you're trying to figure out, well, what are the coordinates almost that give me that?
Okay.
So if you were to look at this on a table, then I'm looking like right here. and that 0.8106 would be inside the table.
But I thought we were starting with a Z line. Why are we looking inside the table to start? We didn't.
So we started with a probability, and we're trying to go back to X space. We weren't given a Z value to start with.
Oh, I saw Z81 on the chart. I got a little confused. Okay.
Yeah, that was supposed to be like a Z sub 81. So it kind of looked like the other problems that we were doing before, like the Z sub 15 or 0.15.
Okay.
So that's what was trying to happen there. It just didn't type out correctly because doing math type in Blackboard Collaborate doesn't really work.
Okay.
Are you okay now?
No, I'm just gonna watch. Thank you.
But now we need to go back to X space. So we know what Z is. We have to find X. Okay.
So even if you weren't given the formula, then you can rederive it from what we know from this one. So X is going to equal, that'll be mu, my average, and then I'm adding sigma times Z. And the way that you get that is just by solving for X. Any questions on that? Okay.
Let's put
I-
the numbers in.
How did you get that second formula? X equals mu plus zeros.
So that's a sigma. So
Right. Where did you get that form? Or how do we know to go to that formula next?
Go back
because we're trying to get back to X. So I want the formula that's solved for X. That's the one that I'm going to use.
all this stuff was on that chart that we went over where the errors were going and things like that. So if you're going from X to Z, you use the top one. If you're going from Z to X, you can use the bottom one. So Linda, go ahead and put numbers in here, if you will, please.
Okay. So it's given in the problem that the mean is 50. And then my standard deviation was 7. And my Z-score from what we just found from the table was that 0.88. So when I just plug all this into a calculator, then I get 56.16. So what this means is if you have, or whatever context it is, if you're at 56.16, then you're better than 81% of the population, because that is what we started with.
Okay, Linda, let's go back to the slideshow, and maybe you have that LSA there, but if not, that LSA would be one thing that we could talk about. And again, I know what time it is. I always know what time it is. But do you have that LSA, the other one?
I think I do. I would just have to upload it real quick.
Okay, so Linda's going to throw this up, and I'm going to talk to you about this problem in the context of what we did. Okay?
And I'm bringing up LSA 3, right? Not 4?
I think so.
Okay, I think I have to go grab that one then.
And I'm going to move the due date on that so no one has to get, anxious about the due date.
Okay.
And the reason I'm doing this is someone asked a question about this, so I want to talk a little bit about it. Now, that doesn't mean you're going to understand everything, but maybe when you review the notes and think about things and get something to eat and drink, you might feel good about it. So Linda's going to have that up soon, I think.
Yeah, I'm trying to. For some reason, my computer's not finding it.
It's in the syllabus tab, but maybe that's not.
Yeah, I downloaded it. It's just not appearing in my actual computer.
Okay.
Let me try something else.
Okay.
Unless you wanted to write on it.
What I'm going to do is I'm going to kind of tee that problem up for you just briefly. I'm not going to work it. There it is. Thank you. All right, here we go. I'm going to read a little bit and bear with me. This will be worthwhile, I think. The time required for Speedy Lube to complete an oil change on an automobile follows a normal distribution. The mean is 17. That means the average is 17. And the standard deviation is 2.5. That information is in X space because it's not mean 0 and standard deviation 1. So this is in X space. Okay, so that's in X space. Then the question tells you, so that means in X space you have a normal mean of 17 and standard deviation of 2.5. Now Speedy Lube guarantees customers that the service will take no longer than 20 minutes. If it does take longer, the student will receive the service for half price. What percent of the customers will receive the service for half price? Okay, so you have to think about what you draw here. And let's see, I can't draw on this the way it is, I think. But
You want me to
see,
switch back to a whiteboard?
yeah, and I'm not going to remember the numbers, but anyway, so we're in X space.
So the mean is 17 and the standard deviation is 2.5.
Okay, so this is 17 that is in the middle of this. So this is 17. And this is 17. And the standard deviation was, Linda, you said 2.5?
Yes.
Okay, so this is normal. And this is normal. This is 17 and comma 2.5. And these are minutes. Okay, now that is X space. It's important that you have this understanding that this is X space. So I'm going to go down here and I'm making a note that that is X space. But now what they said is that we want to find what probability of customers have a service time that is more than 20 minutes. So what I'm going to do is I'm going to say, well, where is 20? Where is 20? And 20 is over here. So there is 20. And the area I'm trying to find is this area to be 20. I mean, this is 20, and you want to find the percentage. So I want to find this area right here. Now that's going to be 1 minus this. Now, but how am I going to do this? Well, I have to change this to Z space to do the problem. And how I'm going to do that? I'm going to do Z equal X minus mu all over sigma. Okay. Now, if we go back, and some students are just leaving, so we're going to be finished real soon. And Kathy, I'm going to finish what I was saying, and then I'm going to go back. Linda, go back to just the slide again, and then we'll I want to entertain Kathy's question, but I'm going to just wrap this up because students are leaving and they're not benefiting from the discussion we're doing. So.
There we go.
Okay, I wanted to go back to the Jiffy Lube. I'm just going to say I helped you some with that. I'm going to extend the deadline on this. Yes, Kathy?
I was wondering, why did you have to go to Z space? Couldn't you figure it with the information on the first bell chart or bell curve you drew, the X space?
No.
Okay. I thought you could
because you don't have any table.
you couldn't
You
find
don't have.
standard deviation.
I told you what the standard deviation was. Okay, Kathy, I'm going to stay and talk with you
Yeah.
here,
Okay.
but everybody else, you guys are all dismissed. I will change the due date on that probably during my office hours. No, Kathy, in X space, you don't have a table for X space. You only have a table for Z space. Okay. So you don't have a table for X space. And we're not teaching you how to do that problem in X space. We're just teaching you how to do that problem in Z space. So what you have is I can draw the picture, but I have to figure out what that is in the other space. Because Kathy, you only have a table for what space, X or Z?
X space, and I the way I think
No,
I'm
no, no,
misunderstanding.
no, no. You don't have a table for X space. The only place you have X space is the real world.
Oh, you mean the chart? No, I didn't know we needed to use the chart at all. I thought we could figure it using that 68, 95, that
No,
percentage with
no,
the
no.
standard line.
Yeah,
Oh,
only if you're lucky enough to land on standard deviations, and I don't think that problem was landing exactly on standard deviations. So you do have to go back to Z space.
okay.
All right. Okay. And Kathy, I'm willing to talk more with you. In fact, I'm going into my office hours right
Yeah,
now.
I was already
Our
having.
pursuit, but if you want to head there, we can talk more
Yeah.
about these things there. And anyway, it's totally up to you. But we're finished, and I am going to change the due date on that other thing to make it after we meet again, and that way people will have the opportunity to have some more discussion. Okay?
Can I just ask one more thing on that?
Yeah, I don't know who I'm talking to, but that's okay.
This is Lori. And
Okay,
it just
Lori.
goes back to my question at the very beginning of class is how are we putting this into Excel? Because I could do this problem, but I couldn't do it in Excel. And that's why I said, are we doing all these in Excel?
Well,
Was this a problem
actually,
that does not happen in Excel?
well, I will tell you what I would do if I were doing this problem. I would look up those numbers, but I would do the calculations that Linda was doing by hand and with her calculator. I would be doing that in Excel, but you don't have to use Excel for these problems.
But you don't need to draw the bell-shaped curve that you're doing, you're
No,
utilizing. No,
you,
okay.
Not necessarily, but you should.
I'm going to tell you, if you look at what it says right here on the chart that Linda says, and this is Michael Sullivan in his book, be sure to draw a normal curve with the area corresponding to the probability shaded. Most students
But
aren't
you
good
can't do
enough
that
to.
in Excel, correct? Or we don't have the capability of doing that
No,
in
you
Excel.
No, so you would just draw it by hand.
Okay,
The
that's fine.
slop.
That's what I did. I just wanted to make sure I was understanding that I can't do the bell-shaped curve in Excel. I can do the problems, but that is more of an by hand thing.
Right, but
Okay.
it's really important to draw the pictures. Really
Yes,
important.
I have drawn it already. I just wasn't sure how to transfer it, but I don't have to, is what you're saying.
I think we're all good, yes. Okay. Linda, you stop this recording?
Yes, I will now.